All right, in this video, we are going to do another example from the graph sine and cosine functions Newton assignment. And says, so the problem is find the equation of the graph given below. Notice that the cosine function is used in the answer template, representing a cosine function that is shifted and or reflected. Use the variable x in your equation rather than the multiplication times symbol, and provide your answer below. All right, and so you can see in the answer, there's three answer blanks: y equals blank, cosine of blank plus blank. And so what we'll need to do is to go through and pick out some of the features of the graph and then figure out what the numbers are going to be in these answer blanks. All right, so to do that, we are going to find the period, phase shift, amplitude, vertical shift or midline of these of this graph right here. Okay, so the first thing that we're going to do is look at the period. All right, and so the period we're going to get by using these 2 points, right, that they gave us. Okay, and so that is going to be taking this number here, right, the y coordinate here, 5/4, right, and subtracting pi, or 5 pi over 4 rather, and subtracting pi over 4. All right, you can see these are consecutive low points or minimum values, however you want to say that. And so all we need to do is find the distance from here to here. And you can do that by taking the x coordinate of this point on the right, 5 pi over 4, and subtracting off the x coordinate of this point over here on the left. So that's going to be 5 pi over 4 minus pi over 4. And so when I do that, I'm going to get 4 pi over 4. Right, these fractions have a common denominator, so I can just subtract the numerators. 5 pi's minus 1 pi is 4 pi's, and then keep the same denominator. And then I can simplify that, right? 4 divided by 4 is 1, so that's the same as 1 pi. All right, so that's the period. So the phase shift, in general, that can be kind of complicated and there's a lot of choices, but really what you need to do is go with the x coordinate on this leftmost point on these Newton problems that we're doing on this assignment. Okay, in general, you could pick, there's lots of ways you could do this, but just go with that on these Newton assignments. So the phase shift is going to be pi over 4. All right, next up, what we need is the midline. This one is a little bit hard to see, right? And because they don't really give us a point here on top, right? Which is kind of unfortunate. Or these it really would be nice if they gave us at least a y value here. So we just kind of have to guess a little bit on this one, in my opinion. So we can see that the y value of these minimum points where these absolute minimums occur is minus 1.5. And then up at the top, it kind of looks like it's a half, right? Negative a half, rather, where these are. So negative 1/2 and negative 1.5, the midline, right, would be at negative 1. So the vertical shift or midline is going to be at negative 1. And again, you can do that by doing minus 1.5 minus a negative 1, like so, or minus negative 0.5 rather, and divided by 2 by taking the average of the minimum values and the maximum values, or average, sorry, and it would be plus here. So that would be minus 2.0 divided by 2, which comes to minus 1. Okay. So that's where the vertical shift is, and then, or the midline, however you want to say it. And then the other thing we need is the amplitude, right? So the amplitude would be the distance from the midline minus 1, right, down to the minimum or up to the maximum value, right? The midline's halfway in between. So we can see that the distance would be a half, okay? Because the midline's at -1, and then the minimum value is minus 1.5. Okay, so the distance there is negative, or if you subtract them, you'll get negative 0.5. The absolute value of that's a half. The amplitude is 1/2. Okay. All right. So now that we have all of those values, right? Again, our answer in this spot, we'll need to put the value of a. In the second spot, we'll need to put the value of bx minus c. In the third spot, we'll put the value of d. Okay. So you can't just stuff these numbers in there. You have to make a few calculations. So first off, let's start with the amplitude. The amplitude, right, is the formula for that we went over, is that it's the absolute value of a, right, where a is, remember our format for our sinusoidal functions is y equals a, and then for this problem it's going to be cosine bx minus c plus d. All right, so that's what we're working with. So this number that goes out in front of the cosine is going to be the absolute value of it is going to be the amplitude. So the amplitude is 1/2. And if the absolute value of a is 1/2, that gives us two choices, either the negative 1/2 or positive 1/2. And so we're going to have to decide which one are we going to go with in this problem. All right. So what you have to do is go back to the graph, right, and that point that they gave you, right? Remember this leftmost point that we got the phase shift from. Imagine that is going to be the point that you're going to use to decide whether or not you should choose the positive value for the amplitude or for the negative value for the amplitude. Okay, and you have to think back to how the basic cosine looks, right? So the basic cosine function looks like this. When it starts at 0, it starts up at the top and it goes down like this. Okay. If you change the amplitude, if the amplitude is negative, right, it's going to start at the bottom, right, and then go to the top. And so based on that, when we go back and look at the graph, right, we can see that starting at that leftmost point that they gave us, we can see that it's starting at the bottom, at a low point and going up, right? So what that means is that the number out in front of the cosine will be a negative number. So what we need to do is to choose this negative 1/2 as the value for a, okay? So again, that's going to be based on how, in this case, the basic cosine function looks. If it was a sine problem, you'd use the basic sine to decide, and that leftmost point that they give you on these problems, okay? In reality, you can kind of, make it how you want to, but we'll not go into that detail. So use this point over here as the basis for your decision, like I just showed you. Okay. D is just the vertical shift, right? And so D is equal to -1. So that's easy. So the vertical shift is D, right? And we already know by looking at the graph that the vertical shift is -1. So that part's done. Now what we need to do is focus on the period. And that would be B. So remember the period, formula for the period is 2 pi over the absolute value of B is the period. In this case, we got from the graph that the period is pi, right? So we know that the period is pi. You can write that as a fraction and then just cross multiply. What we want to do is solve for the absolute value of B. So cross multiplying here, we get 2 pi. The other is pi times the absolute value of B. And we can get the absolute value of b by itself by dividing pi, both sides by pi. So you get the absolute value of b equals 2. So that means that b is equal to 2 or minus 2, right? And so remember I said on these, on the period, when you're finding b, just choose the positive one, okay? I already mentioned there's lots of different ways you could do this, but just on these Newton problems, just choose the positive one for b. For a, you're going to have to make that decision like I showed you, but for b, I'm pretty sure on all of these they're just using the positive one. Otherwise, it would make it a lot more difficult. All right, that brings us to the phase shift, right? And we know that the phase shift is equal to c over b. Again, I'm going to warn you, right? For these problems, that's what they're using, c over b. This formula is based on the fact that we are using a minus here, right? If you're looking at another source that uses a plus, then they're going to give minus c over b as the formula for the phase shift. But if you do that on these problems, you're going to get it incorrect, okay? All right, we already know that the phase shift was pi over 4. C we don't know yet, but we do know b is 2. All right, so that gives us a little equation to solve, and again, just cross multiply. Pi times 2 is 2 pi. 4 times c is 4c. And divide both sides by 4. So over here on the left-hand side, 2 goes into itself once. It goes into 4 twice. So we get pi times 1 on top, which is just pi, and 2 on the bottom. And over on the right side, we get c. Okay. Right, we found b and c. Remember, our answer in that middle slot is going to be bx minus c, just like this form here. So b is 2. And then minus. And then c is pi over 2. So that's what it's going to look like when we type that in, okay, in that middle slot. All right, so negative 1/2, 2x minus pi over 2, and negative 1. So let's go ahead and type that in. All right, so the amplitude was 1/2, or negative 1/2. All right, the cosine was, or inside was 2x minus pi. Oops, I forgot you got to do it like this on Newton. Pi over 2. Nope. All right, and then the vertical shift, our midline, right, was at negative 1. So that's what it looks like. Negative 1/2, 2x minus pi over 2, and negative 1. So, and there we go. Okay. All right, and that is it on this one.